Hi, I'm Brooke from GalaxyPhi Math, and please comment on what free videos do you need help with? Like what algebra through calculus, tell me what you need. Tell me what you need help with, and I will get it made for you. Check out my YouTube video and don't forget to like and subscribe. Thanks. Okay, so we're gonna start with square roots. And when you take the square root of a number, just any number, you're looking for the positive square root. Sometimes people will put plus or minus the answer, and that's not actually correct. In general, you have to write a negative in front of the square root sign in order to actually see the negative. And this can be shown by the graphs of the square root of x. So you only see the positive values of x when you graph the square root of x. You actually have to put in negative square root of x to see the other half of that curve. So you're not automatically, anytime you take the square root of a number, going to get the plus and minus. Now, where this is applicable, where you will always see plus and minus, is when you're dealing with quadratic equations and the theorem of two squares, which states that if p and q are real numbers, and if p squared equals q squared, then p equals q, and it can also equal negative q. And we can kind of look at an example to illustrate this. Okay, so you have 3 times 3 is 9, but there's another number that when you multiply by itself equals 9, that would be negative 3. So negative 3 times negative 3 is 9. So p equals 3, and p also could equal negative 3, one of the two. So you can use plus or minus in this situation. So I'm going to challenge you, just because it makes life a lot easier, and you can do a lot of estimation on standardized tests and, well, any other tests as well. But sometimes these square roots work out, sometimes they don't. But when they do, it would be nice to know off the top of your head what the square root is, or the square. So I would definitely suggest memorizing the square roots, at least up to the square root of 400. Okay, so let's try an example. If we have p squared equals 121, and we know that our theorem states that if p squared equals q squared, and we're assuming that these are real numbers, then there are two solutions where p equals q and p equals negative q. So we have two different answers that can be plus and minus. So since we know our perfect square of 121 is 11, we're able to quickly answer that one. Plus or minus 11 is the answer. Okay, for the second example, we have p squared equals 37. And so it's not obviously an easy square to come up with, so we are going to figure out a trick to make it a little simpler. So we know from the theorem that if p squared equals q squared, and that these two numbers are real numbers, then we have two solutions. We can either have p equals q or p equals negative q. So let's come over to the side here, and we can see that 37 equals, it's the same thing as the square root of 37 squared. So you can rewrite it as 37 to the half power, because that is the meaning of the square root, and then square it, and that is literally the same thing as 37. So let's look at this a different way. We have p squared equals 37, the square root of 37 squared. And so then we're left with p equals plus or minus the square root of 37. Okay, for number 3, we have p squared equals 11. This is also not one that can be easily figured out with a quick square root or perfect square, but walking through the steps of the last one, we can see that p will be the same as plus or minus the square root of 11. Okay, all right, so for now, let's work on some square root practice and see, gather some friends and family and see how fast y'all can answer these problems. Okay, 10, 17, 15, 17, 4, 14, 11, 19, 18, 16, 14, 17,